The aim of this experiment is to validate neural network based guidance scheme that is designed for a re-entry vehicle which is space shuttle. As we don't have a real flight vehicle, the re-entry vehicle dynamics are executed in real time using OpenLAT OP4510 real-time simulator. And the neural network based guidance scheme that we have designed is dumped into this controller, which is TMS28335. The neural network is basically trained with time series data of altitude, velocity as input, altitude and velocity of the vehicle as input, and angle of attack and bank angle. It is trained offline and it is dumped into the controller so that in real time, based on the current altitude and velocity of the vehicle, the neural network based controller would be able to give angle of attack and bank angle commands to the real time simulator. So let us have a look at the physical hardware setup. This is the real time simulator OP4510, in which the re-entry vehicle dynamics are run in real time. And this is the controller board. This is the controller TMS28335. This controller board will facilitate the connection between the controller and the real-time simulator. You can see that the output of the controller is going as input to the real-time simulator, and the output of real-time simulator is the input to the controller. It is done through this DB37 connectors. So let us have a look at, so I'll show you the neural network based guidance, neural network based controller that we have designed in the MATLAB. So this is the neural network which is trained for the input altitude, velocity of the vehicle, and the output is angle of attack and bank angle. So in order to, this is in MATLAB. So in order to deploy it to the hardware, we'll click here. Let us click again. Okay, it is done. Now we use Code Composer Studio, where the generated map and out files are to be browsed. Apply and close. Now I can run. So the main purpose is the MATLAB code is being dumped, is being converted to C program here using Code Composer Studio. And this debug probe here, JTAG would help us connecting the PC with the controller. So now I am running the controller part. Let us go to the real-time simulation part. We have RT lab here. The model which has the re-entry vehicle dynamics is again in a MATLAB function. So we have re-entry vehicle dynamics here. So in RT lab, we will build the model, load the model, and now I am going to execute the model. So you can see that these two are the angle of attack and bank angle commands that we are receiving from the controller. We can also see how this plot here shows how altitude of the vehicle is decreasing with respect to time in real time, and this is velocity of the vehicle. You can see that velocity is decreasing. This is flight path angle of the vehicle, This is latitude, longitude and heading angle of the vehicle. So we can monitor how the altitude of the vehicle is decreasing in real time. So you can see that the velocity is also decreasing. So using this hardware in loop setup, we can validate any guidance algorithm that we have developed for any kind of flight vehicle. Thank you.